Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions on mechanics from October-November 2021, paper 1. In the last class, we have discussed from question 1 to question 10, and the solution of those questions you can find in mechanics part 01. In today's class, we will start from question number 11, and we will try to improve our conceptual understanding of mechanics by solving past paper questions. Let's study together. Let's improve together. For our question number 11, it is given to us a spherical object falls through water at a constant speed. Three forces act on the object. Which diagram showing these three forces to scale is correct? Now we need to understand it is given to us constant speed. So constant speed simply means that F net on the particle means on object is equal to 0. It simply means that forces are balanced. So if forces are balanced, so it means that sum of upward forces has to be equal to sum of downward forces. So this is the key concept we need. Now if you look at figure D, means the option D, this is not possible because these forces are smaller than this one. So it simply means that there is net force that is acting downwards. It means this spherical object is accelerating downwards. Now if you look at the second one, is also true because the sum of these forces is less than this one. So in this case there is also net force that is acting downwards, and this spherical object in this case will be accelerating. If you look at option B, you can see we have this arrow. If I place this arrow here, let's say this arrow is here. Now if you look at these two, they are almost equal. So in this case we can say upward force is equal to downward force. So in this case F net is equal to 0. So the speed of the object will be constant, or you can say acceleration of the object is equal to 0. So this can be the answer. Now if you look at option A, in this case you can see upward arrow, this arrow, the length of this arrow is almost equal to this one. So in this case it simply means that there is net force that is upwards. So there is acceleration that is also acting upwards. So it simply means that this spherical object is accelerating upwards. So A is not possible answer. C is not possible answer. D is not possible answer. So the best possible option for this question is B. For question number 12, it is given to us two forces act as a couple. Which statement about the two forces must not be correct? So first of all, let's try to understand what is couple. When two forces they form a couple, these two forces must be equal in magnitude, and these two forces must be acting in opposite directions, and these two forces should not act along the same line. Means these forces they cannot act like this. So this one is wrong, and these forces has to be separated. So let me write down here some points. First of all, they must have equal magnitude. Equal magnitude. Second, these forces must be in opposite directions. So we can say in opposite directions. Third, these forces has to be separated. There must be separation between lines of action of these forces. Lines of action of these forces. It simply means that if we draw the line of action of this force is acting along this line, and this force is acting along this line. So there is separation between these two forces. Now let's look at given options. It is given to us they act along the same straight line. It simply means that there is no separation between these forces if they act along the same line. So it simply means that this is telling us we have some rod here, one force is acting down and other force is acting up. Means they are acting along the same line. So this is not condition for a couple. Condition for a couple is there must be separation between lines of action of forces. So this one is wrong. So our answer can be A, because we need to find out which one must not be correct. correct. So this option is not correct. So this can be the answer. Let's go to second part. They act in opposite directions. This is true for a couple. Opposite directions. Same type of force. This is also true. They have the same magnitude. This is also true. So you can also write down same type of forces. Same type. So the answer for this question is A. This statement is true, this statement is true, this statement is true. But this statement is false. So the answer is A. For question number 13, it is given to us a sign outside a shop is suspended from a rusty horizontal hinge at its top end. The sign hangs in equilibrium at an angle of 25 degrees to the vertical, as shown in this figure. Hinge is located at this point. The sign is the square of side length equal to 52 centimeters and it has uniform thickness. It has a mass of 36 kgs. We need to find out what is the moment of the weight of the sign about the hinge. First of all, we need to look at shape of the sign. Shape of the sign is square, mean each side is equal in length. So simply we can say one side is equal to 52 centimeters and it has uniform thickness. In the picture, means in this figure, we are looking at this one from one side. So simply you can imagine that in this case, we are looking from one side. So we are looking from this side. So we will see one side. So this one is 52 centimeters in length. So we can say the center of this one is here. So the distance of the center from hinge is equal to 26 centimeters. And this is uniform. It means the weight of this one is acting at its midpoint. So we can draw weight. So this is weight is acting here. Now we need to find out moment due to this weight. We can answer this question using two different methods. One method we can resolve distance into two parts. So first of all, we can draw line of action of weight, and this is the perpendicular distance, means the perpendicular distance between line of action of the weight and the pivot is this one. We need to find out value of this. Now you need to understand, in this case, this angle is 25 degrees. So this angle will be 90 minus 25 and this will be 25 degree as well. So this angle will be 25 degrees. Now simply we can redraw this triangle. So you can see we have this triangle. So this one is over triangle. This angle is 25 degrees and the length of this side is 26 centimeters. We need to find out x. So x is simply equal to, with respect to this angle, this side will be equal to 26 sine of 25 degrees. Now simply we need to find moment. So the moment will be equal to weight, means the force, time perpendicular distance. So we can say perpendicular distance from the pivot. Weight is given. Weight is equal to 36 kgs mass. We need to multiply by 9.81. And now we need to multiply with perpendicular distance. Perpendicular distance is 26 centimeters. So we can multiply this one with 10 to negative 2 times sine of 25 degrees. So if we solve this one, our final answer will be 39 newtons meter. So the answer for this question is A. So this is one way we can calculate value of moment. Now let's try to answer this question using a different method. In this method, we will resolve weight into its components. So this is weight that is acting vertically downwards. If we extend this one, means if we draw line of action of weight, so this is line of action of weight, and the angle between rod and line of action of weight is 25 degrees. We have already discussed this point. Now if you get alternate angle, means this angle also will be equal to 25 degrees because alternate angles are equal. Now we need to resolve weight into its components. So we will take one component along this rod and one component we will take perpendicular to this signboard, or simply you can say rod. In this case, the component with angle, this one will be W cosine of 25 degrees and component opposite to angle, that one will be W sine of 25 degrees. Now if you look at the angle between line joining the hinge and point of action of weight, angle is 90 degrees. So simply we can calculate moment in this case will be equal to perpendicular component of weight times the distance from the pivot. In this case simply we can say this is W sine of 25 degrees times d, the distance. W is equal to mg, so we can write down mg sine of 25 degrees times d. Now we can plug in values. M is equal to 36 kgs, g is equal to 9.81, and sine of 25 degrees. D is equal to 26 centimeters. So 26 times 10 to negative 2. Now if we solve this one, the value of moment will be equal to 39 newtons meter, and this moment will be clockwise. Question is not asking us for direction, but this one will be clockwise. So the answer for this question is A. For question number 14, it is given to us a uniform rod of length 200 centimeters is freely pivoted at point P. The rod is held horizontally in equilibrium by a 60 newtons weight that is attached to the rod by a string passing over a frictionless pulley. We need to find out what is the weight of the rod. Very practical question. So you can imagine that in this case we can find the weight of the rod using this setup. So just try to imagine this one. So you don't need any other instrument or operators. Simply with this setup you can find the weight of the rod using principle of physics. Let's try to find out the weight of this rod. Pivot is at this point, so simply we can draw this small triangle, means the pivot is at this point. Now we need to understand this weight is not moving up and not moving down. It means that the force acting up here, this force has to be equal to 60 newtons. It means tension in this string is equal to 60 newtons. So the tension here also has to be equal to 60 newtons. Now simply we can resolve this one into two components. So one component, this is cosine. We can write down this is 60 cosine of 30 degrees, and this one will be 60 sine of 30 degrees. Sine of 30 degrees. Sine of 30 degrees is equal to 1 by 2. So we can say 60 times 1 by 2. This is equal to 30 newtons. So the force acting here is 30 newtons. So we can draw this one here so you can see the clear picture. So the force acting here, this force is 30 newtons. There will be moment due to this component of tension because this angle is 90 degrees. But due to this component, there will be no moment because this component of the force is passing through pivot. So there is no moment due to this component, but there is moment due to this component of tension. We need to find out where weight is acting. For this question, it is given to us the rod is uniform. So it simply means that the weight of this rod is acting at its midpoint. So the weight is acting here, and this is what we need to find out. Now we can find out the distance between pivot and the weight. Distance between the pivot and the weight will be 60 centimeters, and the distance between this component of tension and pivot, this distance will be equal to 160 centimeters. Moment due to weight will be clockwise because you can see the pivot is located here and the force is acting here. So the moment due to this one will be clockwise, and moment due to component of tension, this will be anti-clockwise. For this question, it is given to us the rod is in equilibrium. It simply means that the net torque is equal to 0. Or simply we can say clockwise moment has to be equal to counterclockwise moment. Moment due to weight is clockwise, so that one will be equal to 0.60 times W, and this one has has to be equal to counterclockwise moment due to component of tension, and that one is 30 newtons time the distance, perpendicular distance between this component of tension and the pivot, that is equal to 160 centimeters, or simply we can say 1.60 meters. From here we can find value of W. Value of W will be equal to 80 newtons. So the weight is equal to 80 newtons. So the answer for this question is 80 newtons, or simply you can say the answer is C. For question number 15, it is given to us the diagram shows two blocks X and Y. So this is block X and this is block Y. For block X, it is given to us, it has sides of length A, and block X is placed in a liquid of density rho with a shaded face level with the liquid surface. It experiences an upthrust U. Block Y has horizontal sides of length A and 2A and height is 1 by 2A. Block Y is placed in a liquid of density 2 rho, also with the shaded face level with the liquid surface. We need to find out what is upthrust on block Y. Very nice question. Let's try to do this one step by step so you can have clear understanding. In this case, if you look at block X, for block X it is given to us upthrust is equal to U, and upthrust is equal to density of the fluid times volume of fluid displaced times G. So this is density of fluid. This is volume of fluid displaced. For this question, it is given to us the shaded face is leveled with the liquid surface. Let's try to understand meaning of that. Level with liquid surface. So simply we can write on here level with liquid surface. It simply means that block is fully submerged in liquid. We can simply write down fully submerged in liquid. So another way we can say fully submerged in liquid. So this is what it meant by level with liquid surface. It also means that volume of the block, we can say volume of block in this case is equal to volume of fluid displaced. So we can say volume of fluid displaced, or you can say volume of fluid displaced is equal to volume of block. Very important point. Now we will use this one and we will try to answer. Now in this case we need to understand rho is density of fluid, V is volume of fluid, and volume of fluid displaced is equal to volume of block, and volume of block X, volume of block X is equal to AQ. So this is equal to A times Q times G. So this is value of UX. So UX simply is equal to rho F times A cube times G. For this question, density of fluid is given, so simply we can write down Ux is equal to density of fluid, that is equal to rho, so simply we can enter here rho times A cube times G. So this is value of Ux. Now let's try to find out value of Uy, means upthrust on block Y. So we have to take density of fluid time volume of fluid displaced times G. In this case, volume of fluid displaced, this is equal to volume of block Y. So simply we can write on here, this will be equal to density of fluid time volume of fluid displaced. Volume of fluid displaced is equal to volume of block. Volume of block is 2 times A times 1 by 2A times A, and this has to be multiplied with G. So these two we can cancel with this two. So we left with density of fluid times A cube times G. If you look at density of fluid for the block Y, density of the fluid is 2 rho. So we can replace density of fluid with 2 rho. So simply we can say 2 rho times A cube times G. So if we take 2 common, we can write down this is rho A cube times G, and this is equal to Ux times 2. So the Uy is equal to 2 times of Ux, or simply we can say Uy, this is equal to 2 times U, because because ux is equal to u. This is given to us in this question. In the question it is given to us, it experiences an upthrust of u. So simply we can replace ux with u. So the answer for this question is C.